So, page 83, number 31, a athlete runs off of a cliff with a velocity of 1.20 meters per second. The cliff, or the platform, is 10 meters off the ground. And the question is, when the diver jumps into the water, right before the diver hits the water, what is the final velocity? So basically what you have to do is you have to figure out the final velocity in the x direction and the final velocity in the y direction. And then once you have those two velocities, then you can find the resultant velocity with its magnitude and direction. So, as always, the acceleration in the x direction is 0. Meanwhile, it's accelerating in the y direction, positive 10 meters per second squared. The initial velocity in the x direction is 1.20 meters per second, but the initial velocity in the y direction is 0 meters per second, because at first the object's solely going horizontally. And we also know the distance drops down 10 meters. And what we're trying to figure out is what is the final velocity in the x direction and what is the final velocity in the y direction. And as soon as we get these two final velocities, we could just find the resultant to get the total resultant velocity. Some people think that the final velocity is going to be 0 because it hits the ground and stops. But anytime you're asked for the final velocity, it's always the velocity right before it hits the ground, while it's still a projectile. So I'm just going to make my t-chart a little bit bigger down here. X calculations, Y calculations, as well as putting my data either in the X column or the Y column. I also put my calculations in the X column or the Y column. So here's the thing. We know that the horizontal acceleration is 0. So however fast that projectile is going horizontally, it's always going to be going the same speed horizontally. So right here, it's still going to be going forward 1.2 meters per second. And finally, right before the diver hits the water, he or she's going to be going 1.2 meters per second. So we automatically know that the final velocity is in the x direction is going to be equal to 1.20 meters per second. If you needed a formula, you could say that the F in the x direction equals the I in the x direction plus the acceleration times the time. But since the acceleration is 0, that term goes. So you're left with the final velocity in the x direction equals the initial velocity in the x direction. Now, in terms of the y component, if you look at the data that you have, the easiest way of getting that final velocity in the y direction is to use the no time formula. Vf squared equals Vi squared plus 2ax. And of course, this is the final velocity in the y direction. This is the initial velocity in the y direction, and this is acceleration in the y and x in the y. So we know that the final velocity squared in the y direction would equal the initial velocity, which is 0, two times 10 meters per second squared times the distance the diver drops down, 10 meters. And if you solve that for VFY, you get 14.1 . So the diver is going to be dropping vertically 14.1 meters per second and going horizontally 1.2 meters per second. So wrong. 1.2 . 14.1 . And I find the resultant velocity. So using the Pythagorean theorem, the resultant velocity is 14.2 meters per second, and the angle is 85 degrees clockwise from positive x-axis. Or you could say 85 degrees below the horizontal.